Good evening, and welcome to Star Chat, the podcast where we explore the wonders of the universe and the latest developments in space exploration. As we gaze up at the night sky, filled with billions of stars and galaxies, it's easy to get caught up in the magic of it all. But tonight, we're going to delve into a fascinating aspect of space travel that often goes unappreciated: the curved trajectory of rocket launches. You've probably seen it before. A rocket blasting off from Earth, soaring into the sky, and then, instead of flying straight up, it begins to curve, following a gentle arc as it makes its way into orbit. But have you ever wondered why this is? Why do rockets curve instead of flying straight up? The answer lies in a fundamental concept of physics known as the brachistochrone curve. Imagine a ball rolling down a hill, following the path of least resistance. As it rolls, it will naturally follow a curved trajectory, accelerating downward due to gravity. Similarly, when a rocket launches into space, it must follow a curved path to maximize its energy efficiency and ensure a successful insertion into orbit. This curved trajectory allows the rocket to take advantage of the gravitational influences of both Earth and the Moon, using them to gain speed and altitude. The Artemis, the second mission, which has been making headlines recently, is a perfect example of this concept in action. As the spacecraft embarks on its journey to the Moon, it will follow a carefully calculated curved trajectory, using the gravitational forces of both celestial bodies to achieve its destination with precision and speed. It's a testament to human ingenuity and the power of mathematical modeling that we can design such complex trajectories, leveraging the fundamental laws of physics to explore the cosmos. As we continue to push the boundaries of space exploration, it's essential to remember the importance of critical thinking and skepticism in scientific inquiry. By questioning our assumptions and seeking evidence-based answers, we can drive innovation and advance our understanding of the universe. And as we look up at the stars, filled with billions of galaxies and unexplored worlds, we're reminded of humanity's responsibility to care for our planet and to strive for a deeper understanding of the cosmos. We'll be right back with more fascinating space news on Star Chat. Welcome back to Star Chat as we continue our journey through the vast expanse of space exploration and discovery. Tonight, we're celebrating a significant milestone in international cooperation and the pursuit of advancing human knowledge in space. NASA has announced that Italian astronaut Luca Parmitano will be the lead pilot for the Artemis, the third test flight, marking a historic moment as the first European to join this pivotal mission. As we ponder the significance of this selection, let's take a step back and consider the broader context of space exploration. The inclusion of astronauts from around the world in these missions is a powerful reminder of our shared human aspiration to explore and understand the cosmos. It's a testament to what can be achieved when nations put aside their differences and work together towards a common goal. This collaboration not only enriches our scientific endeavors, but also fosters a sense of global community and cooperation, values that are essential as we venture further into the unknown. The Artemis, the third mission itself, is a critical step in NASA's ambitious plan to return humans to the lunar surface by the end of this decade. By testing the technologies and strategies necessary for a sustainable presence on the Moon, we're not only expanding our knowledge of space, but also paving the way for even more daring endeavors such as manned missions to Mars and beyond. The selection of Luca Parmitano, with his wealth of experience in spaceflight, underscores the importance of skill, dedication, and international collaboration in achieving these goals. As we reflect on this exciting development, let's remember that the pursuit of space exploration is not merely about reaching new destinations, it's also about challenging our current understanding, driving innovation, and inspiring future generations to embrace STEM education and careers. It's a reminder that, despite our differences, we share a common heritage as inhabitants of Earth, and our responsibility to care for our planet is intimately linked with our aspirations to explore the cosmos. The announcement of Luca Parmitano's role in the Artemis III mission is a beacon of hope and cooperation in a world where such values are more important than ever. As we look up at the night sky, filled with billions of stars and galaxies waiting to be explored, we're reminded of the infinite possibilities that lie before us when we work together toward a common dream. Welcome back to Star Chat, where we explore the wonders of the universe and the incredible advancements that are taking us closer to the stars. As we conclude today's journey through space and time, I'd like to share with you a fascinating story about how scientists are revolutionizing the way we grow food, not just for our planet, but for future missions to space. Imagine being able to cultivate crops in the dark, without sunlight, and in environments where traditional farming is impossible. This might sound like science fiction, but researchers have made groundbreaking discoveries that could change the face of agriculture forever. A team led by Professor Robert Jinkerson at UC Riverside has pioneered a new field called electroagriculture, which allows for the direct conversion of atmospheric CO2 into plant biomass without the need for light. This innovative method uses an electrolyzer to turn CO2 into acetate, and then genetically engineered plants that can use this acetate to grow in the absence of sunlight. The implications are staggering. Not only could this technology enable us to grow food in space, but it could also help address food security issues here on Earth by supporting food production in densely populated areas, harsh environments, or under disaster scenarios. The team has already seen promising results, with an 18-fold increase in efficiency compared to traditional agriculture. They've even tested their approach on the International Space Station and are working on developing energy-efficient crops that can thrive in confined environments. But what's perhaps most exciting is the potential for this technology to have a profound impact on our daily lives. As Professor Jinkerson notes, in 100 to 200 years, our agriculture will look very different. We'll be able to produce food in highly controlled environments, and it's going to be much more sustainable. This could mean producing only the parts of plants that we need, without wasting resources on entire crops. It could also enable the use of plants as factories for producing pharmaceuticals, vaccines, or other high-value ingredients that improve our health, all without competing for farmland. As we look up at the stars and contemplate the vast possibilities that await us in space, it's inspiring to see how innovations like electroagriculture can have a ripple effect, improving lives not just on other planets, but right here on Earth. So let's keep pushing the boundaries of what's possible and exploring the frontiers of science and technology. That's all for today's Star Chat. Remember to like, share, and subscribe, and until next time, remember to keep looking up at the stars.